Hello, this is another video as part of the video series on current electricity. In this video, we are going to look at current and voltage divider rule. So what do I mean by current divider rule or voltage divider rule? So as we discussed in the previous video on parallel and series circuits, that when you have resistors in series, the same current will flow through them, but they will have different potential difference across them. But when you have resistors in parallel, they will have different current flowing through them. So which means the total current that is flowing through the circuit is going to divide when it gets to the node that connects it to the resistor. So let's use a diagram to illustrate this. Let's look at the current divider first. Current divider rule. So how do I share the current among the resistors or between resistors in series when they're between resistors in parallel? Sorry. What do I do? So let's say you have these resistors in parallel. Let's say this is R1 and this is R2. So, and you have this current I as the current that is flowing through the circuits. So let's say you have voltage source here. I don't want to show that now. So if the current is coming that way, when the current gets to the junction or the node, it divides. But it divides depending on the magnitude of this resistor. So if the resistor is large, if this R1 is greater than R2, it means that less current will flow through R1. And if you think about it, resistance is an opposition. It's preventing the current to flow through it. So which means if you have large opposition, then less current will be able to flow. But if you have less opposition, more current will flow through it. So which means, let's say if this is I1, the current that flows through this R1 is I1, and the current that flows through the R2 is I2. So if R1 is greater than R2, it implies that I1 will be less than R2. It will be less than I2, sorry. And if R1 is less than R2, that I1 will be greater than I2, okay? So how do we calculate this current? We can use the current divider rule to obtain the current that flows through this. We can also determine this current if we know this PD, this potential difference. So this potential difference, if you know the potential difference across this resistor, then we can use that to determine this current, because it's going to be V over R1. But there's a quick way of obtaining the current by sharing that current, depending on the magnitude of each of the resistances. So now, let's say the total current is I, and the current that flows through R1 is I1, and the current that flows through R2 is I2. If you recall that current that is shared, this one, will be the sum of these two currents. So I will be I1 plus I2, okay? And we know that I1, the same voltage applies across them. If you remember, in parallel circuits, the voltage is the same. The voltage across this R1 is the same as the voltage across this R2. So, and it's the same as the voltage that is connected at source, V. So, in that case, I can write I1. So I will be V over R1. So if V is the total voltage, or the voltage across these two resistors, and this will be V over R2. Okay, so I can factorize the V out, 1 over R1 plus 1 over R2. So if I simplify this, I will have R1, R2 as the LCM, and this will be R2 plus R1. V equals I. Okay, so by cross multiplying here, I'll have I, R1, R2 equals V to R2 plus R1. So if I divide both sides by R1, R2 plus R1, and I divide this by R1, R2 plus R1, R1 plus R2, doesn't matter. So this will cancel that, and this will cancel this R1. So I will have R2 divided by R1 plus R2 equals V over R1. V over R1. So if you recall from Ohm's law, V over R1 should be I1 because, V equals IR. So the current that flows through this will be divided by R. So I1, R1. So this should be I1. So I can replace this with I1. I will have I R2 over R1 plus R2 equals I1. So it means that the current that flows through the resistor R1 will be equal to R2, this is the second resistor, divided by R1 plus R2, multiplied by I. So this is the formula. How does it work? If you look at this, intuitively, we can see that it makes sense. You are just sharing the current in a ratio, just like we have a ratio. Remember, if you want to do ratio, let's say you are sharing 10 in the ratio, let's say 2 to 3. So if you want to get the amount for ratio 2, you will do 2 out of the total ratio multiplied by what they are sharing. So, and if you want to get for 3, it's going to be the 3 divided by total ratio multiplied by what they are sharing. Okay, it's similar to what I'm doing here. The only difference is that instead of me using this ratio, I'm using this because I know that the current should be less if the resistance is high. Okay, so if you want to calculate, similarly, if you want to calculate I2 should be equal to, then you use this other resistance R1 divided by the total resistance multiplied by what they are sharing, the current. So this formula is what I refer to as the current divider. Okay, so if I know the resistance values and I know the total current, I can just determine the current in each of those arms by applying this formula. Okay, now let's look at the voltage divider. Now for the voltage divider, I will have resistors in series. Let's say I have these two resistors in series. Then, and this is the total voltage. Total voltage across them is V. This voltage here is V. So if this is R1 and this is R2, then this is V1 and this V2. So the voltage across R1 is V1 and the voltage across R2 is V2. As we learned in the previous video, under series and parallel, that when resistors are connected in series, the same current will flow through them, but they will have different voltages accordingly. So from here, we can see that V will be V1 plus V2. Okay, so what we want to do is we want to calculate the voltage. How do we share the voltage? Okay, so if I know the resistances, what I can do now is to replace from Ohm's law, V equals IR. Okay, so by replace that here, I'll have V equals V1 will be I R1 because I know that the same current will flow through them. So I'll keep the I for both of them, and this will be I R2. So the current that flows through this is the same as the current that flows through this. It's the same as the current that flows through the entire circuit. So now I want to share the voltage V. So what can I do here? I can factorize the I that is current, that is common to them. So V will be I into R1 plus R2. Okay, and we make I the subject. I will be V over R1 plus R2. So, but I know that V1 is I R1, and I know that V2 is I R2. If I replace I with this, I'll have V1 to be V over R1 plus R2 multiplied by R1. And this will be V over R1 plus R2 multiplied by R2. So I can rewrite this by 1 as R1 over R1 plus R2 multiplied by V, and V2 equals R2 over R1 plus R2 multiplied by V. Okay, so this I refer to as a voltage divider rule. Now, if we compare this with current divider, you see that for voltage, if you want to calculate the voltage across R1, so you have R1 at the top. You share it just like a normal ratio that we know in mathematics. Okay, the resistor divided by the resistance of the resistor divided by the total resistance times the voltage they are sharing. So and that makes sense because the higher the resistance, the higher the voltage across it. Because we know that R is P. So if this is large, then this will be large. Okay, so that's it for the video, and I'll see you in the next video.